So we're going to view the circuit when t was less than 0. So when t was less than 0, the capacitance becomes an open wire, and the inductor is short-circuited, and the switch is open. So it looks something like this. So this is 10 ohms here, this is 4 ohms here. We have a voltage at this region, and then we have a current passing through here, and this is 3 amps. So now since this is not a closed circuit, our I value here is going to be 0, and our voltage here is going to be 0 because there's no voltage source or proper current passing through here. So, and obviously the current here is 0, so that's another reason. So the current passing through the inductor, obviously when the switch is on, we get a closed circuit, but obviously the current passing through the inductor is still going to be 0 as it can't change instantaneously, and same with the voltage. The second the switch is on, the voltage at the capacitor can't change instantaneously, so that's going to be 0 as well. Now let's view the circuit when t is greater than or equal to 0. So the switch is on. So we have our capacitor. And then we have the last two. So this is 4 ohms, this is 2 henries, 10 ohms, and 1 over 20 farads. So the first thing we're going to do is write the nodal equation at this point. So we have another current, let's call this I1, and this is obviously 3 amps. So 3 amps is equal to this I value plus I1, and I1 can be represented by C times dV over dt, okay? So because of this capacitor. Okay, so right now I'm trying to solve for V. So what I'm going to do next is find the make the transition circuit. So the transition circuit pretty much looks exactly like this, but without any sources. So we just remove this source and we leave it with an open wire. Then let's do a mesh, and let's call this I. It's traveling the same direction as this. So it's just going to be minus V, so minus V, plus 10I, plus 4I, plus the inductance and the change in current over the change in time. Okay, so now what am I going to do? Wait, so let me just add these up. Okay, and all of this is equal to 0. So pretty much what I'm going to do now is isolate for this I. So I'll do 3 minus C dV over dt equals I, and plug this I into here and into here. So it'll be minus 4 plus 14, 3 minus C dV over dt plus L times the derivative of this. So it will be 0 minus C d squared V over dt squared. So that's minus 4 plus 14 times 3, which is 42, minus 14 times the capacitance, dV over dt, plus 0 minus LC, d squared V over dt squared. Now I'm going to bring this, and this all to the other side. So it'll be LC, d squared V over dt squared, plus 14C dV over dt, plus V equals 42. And divide everything by LC. So you get the following. Okay, and recall L was 2 henries, and the capacitance was 1 over 20 farads. Okay, so plugging those values in, we should get the following. So 14 over 2, that's 7. Oh yeah, and this is dV over dt. Sorry, I forgot to add that. So dV over dt plus V over 0.1. Okay, and this becomes 420. So now to get our sigma and our omega, our alpha and our omega, our alpha is going to be this value times 1 over 2, so 7 over 2, and our omega is just going to be, so let me just move the V here, our omega is going to be this value squared. So this is 7 over 2 radians per second, and this is, give me a sec, this is the square root of 10 radians per second. So now, this is what we noticed. We see our alpha is greater than our omega. So that means to find Vt, so V transition T that's passing through the capacitor, it's going to be A1E S1T plus A2E S2T. Okay, and then when we find our S1 values and S2 values, we're going to add the steady state response, and that's going to give us our Vt value, because recall Vt is equal to VTT plus VSST. Okay, you use this formula if if you notice that when you flip the switch on in this circuit and there's still a source in, whether it's a current or voltage source, then you use this formula. So let's find out our S1 and S2 using the following formula. Okay, this is pretty much the quadratic formula that you derive from here. So let's see. This is 7 over 2 squared minus square root of 10 squared. So S1 will be minus 2, S2 will be minus 5. This is VTT equals A1E minus 2T plus A2E minus 5T. Now let's find our steady state voltage. So we pretty much just bring this circuit here, including our source. So let's turn back on our current source. Okay, and we view the circuit when t goes to infinity, because V steady state is equal to V infinity. So this is 1 over 20 farads. This is 10 ohms. This is 4 ohms, and this is 2 henries. So obviously this short circuits, and this becomes an open wire. And we have to find the voltage at this point. So we know the voltage passing through here is going to be 0. So that means this resistor is pretty much just useless. And so that means there's going to be current passing through here. This will be 3 amps. So if we know the voltage at this region, that's the same as the voltage here. So the voltage here should be the same as the voltage here. So it's going to be 4 times 3, which should give you 12 volts, and that's the voltage here, and which is the voltage here. So that means V infinity is going to be 12 volts, and this is your V steady state. So we're just going to add 12 to this, and that gives you your Vt. Now let's find A1 and A2. Recall when t was 0, our voltage at our capacitor was 0. So this is 0 equals A1. This is gone, this is gone. So this is minus 12 equals A1 plus A2. That's our first equation down. Now we need another equation. So we'll have two unknowns and two equations. So let's differentiate all of this. Wait, hold on. There we go. Okay, so now what we need to find is dv over dt at a certain point. So to find that, we're going to pretty much use this formula. So we know when t was 0, our current passing through the inductor was 0. So this is 0. And we know our capacitance, which is 1 over 20. So dv at 0 over dt is going to be 60 volts per second. So here we'll just replace 60 equals minus 2 a1. This is gone, this is gone. Minus 5 a2. Okay, and we should get the following. A1 should be 0 and A2 should be minus 12. Now we can solve for Vt. So Vt should be, so this is 0, so that's gone. So minus 12 E minus 5t plus 12. That's the first bit done. Now we have to find the formula to represent I. So let's bring back this formula. 3 equals I plus C dV over dt. Okay, let me double check. Yep. Okay. Whoops. Hold on. So, wait, sorry. Give me a sec. Okay. There we go. Okay, sorry. My computer was glitching. So, I is obviously C dV over dt minus 3. Wait, hold on. Let me double check this. Sorry. Wait, sorry. I mixed this up. My bad. It's I is equal to 3 minus C dV over dt. And we just plug in V into here. So it'll be 3 minus the capacitance, which is 1 over 20, times minus 12 times minus 5, E minus 5t. And that should give you 3 minus 3 E minus 5t amps. And yeah, those are your answers. Yeah, there we go. Okay,